Welcome to this video that I thought might be helpful in doing this particular small exercise that's not exactly discussed in class or written out in the book. This involves areas of various kinds of shapes in mathematics, and I wanted you to have a verbal and visual understanding of it if you needed one, instead of just reading the information that I have on the sheets. You have the basic shapes and formulas in front of you, and of course, because they are two-dimensional, the answers will be in square feet, square inches, etc., and you know how big I am on units. We have the triangle, square, rectangle, parallelogram, trapezoid, and circle in this particular diagram, and I won't go through these at the moment, but just wanted to let you know that they were here, and you can refer to these visually as you need to. You'll note on your calculator, depending on your calculator, that if you're using a value in the circle for pi right here, I hope you see where I'm circling, pun unintended, with the circle diagram. I'm circling the number. Pi is a special number in mathematics, and without going into detail with it, that number is equal to 3.14, and it goes out for many decimal places as lengthily as you want it to be. You probably have a button on your calculator that has a pi symbol on there. It's a Greek letter of the alphabet. On the calculator online, you might actually see the Greek word pi for pi, and that's the button that you would click on the calculator tab website. We're going to be looking particularly at shapes that are made up of more than one shape. They're called composite. Composite just refers to a combination of several items. So a composite shape would be one that consists of maybe a circle and a rectangle, or a trapezoid and a square. It could be a mixture like this. And I've given you two examples that I've gone through on the paper, but I'll go through these visually with you as well. Sorry about that. So that you can get an idea of what's going on with this, and you can play and replay it as necessary. In the first example, to find the area of a composite shape, what you want to do is to divide it up into two or more of the basic shapes that you saw above, like a rectangle, a triangle, and try to make it as least complex as possible. Calculate the area of each of those little basic shapes and add them together. For example, if I'm looking at figure 1, which I'm going to show in red pen right here, and that's not actually the figure, that's just the illustration I'm using. The actual figure is down here. What's going to happen is I'll take this figure, which looks like maybe a sideways L, and I'm going to divide it. Now again, depending on your mindset, I'll do this both ways, and hopefully I will not confuse anyone, because everyone has different learning styles. I can divide this figure by either drawing a blue line right here where I end up with a yellow shape and a purple shape. I can do it that way, or by erasing these contents, I can divide it this way where I have these two shapes. The trick is trying to find out what the missing numbers are, and you can't go by just what is on the screen. So if you are a very visual learner, you've got to do some thinking here too. You can't just say, well, I'll use the 4, the 8, the 3, and the 7 because they're staring me in the face. You've got to think through it. So I'll erase these and start over. Here's what I'm doing. Let me start with the horizontal line, the one going across first. I'll divide it this way. What I now have is a figure, a rectangle that's represented by the blue right there, and I have another rectangle that, in this case, I'm not very good at this as a left-handed person on a computer, represented by the big green rectangle. Now here are the dimensions. That 7 originally, you have to understand, that 7 originally was for the whole thing. That's the 7 right there. But if I'm just looking at part of that 7, here's what happens. 4 of it is right here in the green. That's 4 of it right there. This side is 4 right here, and so that makes this side also 4. This one all the way across is 8, so this one all the way across is also going to be 8. So this particular area will be 4 times 8. Now if I'm looking at the blue subdivision, the blue little divided shape, I've got 3 across here. Now the trick is, how long is this guy right here? Well, remember that the original number for the whole length was 7. 4 of it was in green, which means this part is also going to be 3, because 3 plus 4 gives me the original 7 that I had a minute ago. So I have a rectangle here, or actually a square, that's 3 by 3. And if I add those together, 4 times 8 is going to give me 32. Let me do this in a different color so it's less confusing. 32. 3 times 3 is going to give me 9. So if I add 32 for one triangle, again I'm going to try to make this color scheme for you. 32 for this rectangle, sorry, and 9 for the other rectangle. The total for that, if I add these together, the two pieces, I'm adding those two areas together, the green area right here and the blue area, the grand total is going to be 41. And you know I'm big on units, so you need to, because these are multiplied together, it's going to be square centimeters. Now I'll check down here in my paper illustration and see if I did it exactly the same way. I did not. Yes, I did. Here's what I've done. Yeah, in this illustration, again, this is the same example as before, except this time what I'll do is I'll divide it vertically. And I've jumped some steps right here, but just to let you see what happens, this red rectangle is going to be, that's pretty easy. That's going to be 3 across and 7 down. So this is going to be 3 times 7. That's the one that's illustrated right here. And that's 21 centimeters. The trick again is for this black smaller rectangle, what's going to happen? Well, we know this side is 4. That's easy. We know this whole thing is 8. And 3 of it is right there. So 8 take away 3 means this part right here is going to be 5, because 5 plus 3 is going to be 8. So this is going to be 4 by 5. That's a total of 20 centimeters. And if I add the 20 and the 21 together, I end up with 41. It's the very same answer, 41, that I got up here in this one. So it doesn't matter which way you divide it. Either way you divide it, you will get the answer 41. I hope that helps. Now, in order to avoid confusion for the very, very visual learner, I'm going to temporarily erase this stuff so that there won't be too much information up on the screen. For some learners, the more information you have on the screen, the more confused their eyes and their visual and their brain gets. So I'm going to erase this stuff temporarily and work with the other example. So again, I'm going to erase this. If you lose me, of course, the beauty of the video is that you can rewind it and play this back. Where in class, if I erase the board, you're going, no, that's too fast. You can rewind this one. Now let's look at the second figure, figure 2, which will be this one right here. Now that one is already divided up for you. That's the beauty of it. The trick is going to be, oh my gosh, how am I going to do that little half circle right there? We've got an easy situation right here in that this one is going to be a rectangle, which is 14 tall, 14 length, times 20. That's going to be 320 square centimeters, because I'm multiplying centimeters times centimeters, so they're square units, 2 dimensions. The trick becomes, oh my gosh, how in the world do I get this little half circle right here? Well, that's a half circle. And the area for a circle, if you look right above that, I'll try to make sure I keep both of these on the screen at once. The area for a circle, you see right here, and again I'll erase some stuff so it's less confusing. The area for a circle is this formula right here. If I want a half a circle, I'm going to say 1/2 times pi, which I told you what that was a minute ago, times the radius square. What in the world is a radius? The radius is halfway across a circle. I know this length right here is 14, because remember in that box earlier, this was 14, I'm drawing, so that part's 14. So if I'm going halfway across it, that's going to make that 7. So my circle, half circle is going to be 1/2 times pi, which I told you is 3.14, times 7 squared. Now if you're putting this in the calculator, you're going to write 1 divided by, or slash 2, times 3.14 times 7, the little exponent symbol, 2 equals. And that's the way you're going to do that particular calculation. And I'm going to make sure, sorry about that screen a second ago, I'm on Windows 8 and it does some crazy stuff sometimes, and I'm trying to work around in my office. You're not seeing this, but I'm working around 2 computers at once, and sometimes this can get a little bit crazy with my laptop. It's been acting up. Anyway, you multiply those guys together, and I'll show this in a little more neat form if I can scoot down here to the lower part of the handout and let you see this. The figure 2, as I said, is divided into a rectangle and a half circle. So again, remember this first part is 14 by 20, and that's where I'm getting the math there. 14 times 20, I don't know what I did a minute ago. 14 times 20, I did the wrong number a minute ago, I'm sorry. 14 times 20 should be 280. I apologize for that. Good thing I checked, right? 14 times 20 is going to be 280 centimeters. That's for the rectangle. For the half circle, remember that this radius right here is going to be 7, half of 14. That's where the 7 comes from. So the formula is 1/2 pi r squared. That's a circle, and that's half a circle. So it's going to be 1/2, or 1 divided by 2, times 3.14 times 7 squared, or 49. And if you do the math on there, you will get 76.93. Do not round it off. So you're going to take the answer that you got for the first part, that was 280 square centimeters, and the part that you got for the circle, half circle, 76.93 square centimeters, and you'll add those numbers together. When you add these numbers together, you'll get the total 356.93 square centimeters. Now, yes, we do use centimeters. A lot of people think, well, we have to use yards and inches because that's all some of us understand in the real world of Cleveland and Gaston counties. But we do use metric units in a lot of applications, even in construction, in nursing, so those do exist. You're asked to do 2 exercises, and one thing I want you to understand about this small exercise, I hope you're reading this video, this will be on test number 3, the last week of class. So if a person does not do the smaller exercises this time, they may have to pay for it. Here's the first exercise. The math department is staying at a hotel with this pool in the back of it. Use the sides marked to calculate the area of the pool. So again, same situation. I've got that L shape, I've got that L shape right there, and I can divide it up into either 2 rectangles this way, or I can divide it into 2 rectangles this way. Totally up to you how you solve the problem, but this should give you a model to go by. The very same thing will happen on the next exercise. Again, you'll submit these online through Blackboard and I'll grade them for you. A child is playing miniature golf on this particular hole. Calculate the area of the green shape. In this case, a lot of ways you can do this. You may have to divide this one into more than 2. You may have to divide it this way, where you've got 1, 2, 3 rectangles. Or you may decide you want to divide it like this, where you have 1, 2, 3. And you've got the dimensions there. If this gives you problems, of course you can get with a buddy in class, classmate, and help out, get some help. Or you can certainly contact me if you need to. Here's another one. And again, is this relevant? Oh, yes it is. Find the area of each room. And this one's already divided for you. Now I made this one very simple. Then add the areas to calculate the square footage for your house. Is this relevant? Well, we live in a house hopefully, or will be. So we have, when we're calculating it, this one's already divided. So we'll do this area, and this area, this area, this area, and then add those together. Hopefully this will give you a good start on this exercise. Again, if you still have problems with the video or with the reading of the paper, get with someone, contact me. Don't wait until the last minute.